Wouldn't it be great if we had a way to send spacecraft from Earth orbit to the Moon, Mars, and beyond, all the way to Pluto, and maybe even farther, without having to use any fuel, make it completely reusable, and accessible to just about anyone on the planet when it was needed, when such a mission needed to be launched? Well, there's a concept I'm here to tell you about called the Momentum Exchange Electrodynamic Tether. Now, this is a project I worked on early in my career that's based on momentum exchange, the same kind of momentum exchange you had as a kid when you had a yo-yo and you stopped yo-yoing and you used it as a slingshot and you let go of it, sending it on its trajectory that hopefully didn't break a window. Well, in this case, our yo-yo is 90 kilometers long. It's in space. It's made out of a material that is resistant to the radiation and atomic oxygen, all the problems in space. It has an anchor, but instead of that being you as you throw the yo-yo, it's a spent upper stage. And instead of the yo-yo, it has a catch mechanism on the end to catch the spacecraft it's going to send into space. Now, this is built in segments. Each segment's about 20 kilometers long. At least one segment is made out of a wire. Why do you do that? So you can reboost the system without using any fuel. You do that electrodynamically. What you're doing is you are collecting electrons from the ionosphere. They're flowing through the tether, and they generate a force due to the interaction with the Earth's magnetic field called the Lorentz force, which pushes on the tether, which can act as a boost system to keep it in space. It's all powered by the sun, so the system has to have solar panels. It has to have the electrodynamic tethers, and it has to be in the ionosphere. Now, it's built in segments. Each segment contains about 20 kilometers of the 80 to 100 kilometer long wire. It's built in a modular fashion, so you can have 4 or 5 of these segments connected together. The cable goes on one. Once it's wound, you add all of the other parts, the electronics, the control system. You might need a little bit of propellant to first stabilize the system when you launch it. You have to attach the solar panels so that you can generate electricity when you're in space. And then it all folds up, and another module identical to it comes along, and the tethers are connected. And then they're stacked together so that they fit in the fairing of the launch vehicle that carries them to space. Doesn't matter what that launch vehicle is. It can be any launch vehicle of sufficient size. And it can be launched from just about anywhere in the world, although the equator is the best place because a mixer tether works best in an equatorial orbit. Now, we all love our rockets, but what this rocket does is it only takes the payload on a suborbital trajectory. What I mean by that is it just basically goes up and down. And when it reaches that high point is when the spacecraft will be released to be caught by the tether system. Now, the tether system itself, as you can see here, is not on that trajectory. It's actually in a circular equatorial orbit. The tether is deployed, and this was demonstrated possible by the tethered satellite system in the early 1990s and by a couple of unmanned vehicles called the Small Expendable Deployer System and the Plasma Motor Generator, which demonstrated both the control and deployment of a 20-kilometer long tether and its electrodynamic reboost. Now, once the tether system is in orbit and it's spinning and it's ready, the science spacecraft, or whatever spacecraft that you want to send beyond low Earth orbit, is launched into space on that suborbital trajectory that I mentioned a few minutes ago. Now, again, this is best accomplished by launching from the equator. We show here a sea launch concept, but it doesn't have to be. There are many countries that are on the equator and could have launch facilities to send this to space. Now, this rocket doesn't have to be a big, powerful rocket because it's just going to deploy the spacecraft. The rocket will come back down. The spacecraft, at the moment it reaches peak height, puts out its grapple fixture, and here comes the rotating momentum tether system that rendezvous with it at precisely the moment of apogee, catches it, imparts some of its rotational energy, and sends it off beyond Earth orbit. Now, what happens to the system is that to conserve momentum, the spacecraft goes out and the tether system is kicked back down. Well, the tether system kicked back down regains its orbital energy with that electrodynamic tether, where the current flowing through the wire interacts with the Earth's magnetic field and reboosts the tether back to altitude so it can be ready for the next mission. This is a completely reusable system, and it is absolutely viable, absolutely possible. I'm just wondering when some entrepreneur is going to approach me and some of my colleagues and say, let's make this happen. This is Les Johnson, your friendly neighborhood rocket scientist, here today talking about Momentum Exchange Electrodynamic Reboost Tethers and a way to reach the solar system without any fuel.